Hi, in this video we'll create function which will help us to calculate distance between hexagons and draw the distance by highlighting intermediate hexagons between hexagon A and B. So let's start from calculating distance. If you open redblobgames.com article about hexagons, you'll see in distance that to calculate distance we need absolute values of subtracting of two hexagons and then divided by 2. So we need to function to subtract two hexagons. In the last video we created cube add function which adds two hexagons. Let's create cube subtract function, and let's use hex A and hex B arguments for better understanding, and we will return this hex where hex A, Q minus R minus S minus hex B, Q. That's it. Okay, hex R minus hex B, hex S minus hex B S. So this will be our subtracting function. Let's continue. We need to create function which will calculate distance. For this we will create function cube distance, and it will take also hex A, hex B, and then it will use cube subtract, this cube subtract, and it will pass these arguments here. And let's use here object destructuring. We'll use three axles. We will need them to find distance. Let's create variable dist, which will be our distance, and let's use absolute values of column axle, row axle, and S axle, and let's divide it by 2 and return distance. Actually we can delete it and just return this. Okay, so now we have a cube distance function. Let's test it. We'll pass it here. Instead consolelog, we'll use consolelog and call it with 2 arguments. First argument will be our hex with 0 axles. Second argument will be our current hex, which we'll calculate here. So let's save, let's reload, let's open console, and we see that from 0 hexagons to next hexagon we have distance 1, 2, 3, 4, 5, 6, 7. So it's working. Let's get rid of our neighbors. We will not draw them here we need to comment them in should component update, and let's use gray color when we draw our hexagonal grid. So we will use gray here and here. Let's save, let's reload. Okay, our hexagonal grid is gray now, so let's find intermediate hexagons between our start hexagon and end hexagon. For this we will use linear interpolation. You can find formula for this here. It's very simple actually, but we need to apply it to not to just numbers but to hexagons. For this we need to start from creating this function. We'll call it linear int, and it will take values a, b and t and return this value. So a, b and t, it's not hexagons. We will pass here columns, then rows, then s. We'll pass here x cells actually. To pass here columns and rows, we need another function, group linear int, and here we will take 3 arguments, and we will return this hex, and we will apply this function to each x cell. This linear int hex a q, then hex b q, then t, then this for rows, and also for SXL. Okay, so now we have distance, and distance is the number of hexagons between start hexagon and end hexagon. We can now use linear interpolation to our hexagons using cube linear interpolation. And now we need to create function. Let's call it get distance line to find coordinates of each intermediate hexagon between these two hexagons and store them in array, then draw them on canvas. So for this we will get distance. We'll use this cube distance function, and it takes 2 arguments, so this function has to take 2 2 arguments, we will create array, empty array, and we will create for loop from I equals 0, I less or equals to distance, and I increment. So in this loop function we need to find, using cube linear interpolation function, find each intermediate hexagon. Then we need to cube round it, because this function will give us negative values, because we use subtracting here, subtract function. Then after cube round we need to convert axes to coordinates of center of our intermediate hexagons. So we need to use 3 functions here. First function will be this. It will take same hexagons start and end, and only this part of arguments will change. You can find explanation about it here in notes, but simply saying, this will take distance. For example, we have 0 hexagon and 0 hexagon and hexagon 5 with column or row 5. So we have 0 and 5, and distance equals to 5. So we delete 1 by 5, and we will get 0.2, and then we will multiply it by 0, and we will get 0. So it will be our 0 hexagon. And then again we divide 1 by 5, and we will get 0.2, and then multiply it by 1. So we'll get 0.2, and we will pass it here and then here, and then here we have 5 minus 0, it will be 5. Then 5 we will multiply by 0.2, and it will be 1, and a here 0, 1 plus 0, 1. So we get 1 hexagon. And then we will take hexagons from 0 to 5. My English language level is not so rich to describe it better to you, but you always can open this article and read it here. It's an amazing article about hexagons and coordinates and math behind it. So we need then, after this, round these values by function this cube round, and then we need to use this hex to pixel function to get x and y coordinates, and we will call this variable center. Then we'll use concat to add each center value to array. It will be an object because this hex to pixel returns point object x and y. So here we type center. Then after this we need to write this array to our state, and we'll do it by this set state. We'll call it current distance line and assign to this our array. So let's save. Let's call this function here. Let's first of all call it, and then consolelog this state. Current distance. Let's save. Let's reload. Okay, and we get our state now. Current 10, 11. Okay, it's our 0 hexagon. Then it's our 1 hexagon. Column, then 2 column. This is the line. So we need to draw it right now. For this we will use should component update method of React. It's very useful method. We'll use current distance line variable from next state so when this state current distance line that doesn't equal to next state current distance line, we get new current distance line state, assign it to this variable, and then we again use loop, for loop from 0 to I less or equal to current distance line array minus 1, sorry, length and then we increment, and at each iteration we will draw hex, and draw hex takes canvas ID, center, color and width, and we'll use these canvas coordinates to draw on it. Then we will pass a center object, and for this we will use this point function, our helper function, and at each iteration we will take each element of the array, and as its object we will get property of this object, and it will be x and Y. And then we will draw it with lime color and width equals to 2. So let's save. Okay, draw neighbors. Okay, we have a typo here. Let's save. So reload, and we see our distance actually. And you see that our current hex goes beyond our hexagonal grid. Let's correct it. We'll take this condition from draw hexes, go to handle mouse, move. We can delete our console log right now. And then we need hex width and canvas width parameters, and we will take them from draw hexes too. We will pass them here, and we will update state only when our current hexagon located in the frame of our hexagonal grid. Let's save, and you see that it is not drawing beyond our hexagonal grid. Let's commit. Okay. Calculating distance. Okay, we created our commit. If you like this video, give the video a thumbs up and subscribe to the channel for the new videos. Thanks for watching.